Hi, welcome back to Embedded Programming. So today I'm going to try and root cause or see if I can understand what's going on with this board and why it's not working. Now I've ordered another board, which I didn't realize I ordered the unassembled version. So this is the DC/stepper motor hat from Adafruit. And so I have the board in there with all the pieces. So I have to spend some time assembling this week. And then next week I'll make a video. We'll test this one out. The nice thing about this board is that it supports, I think, up to 4 DC motors also. You can probably see, you know what? Let me actually get in there. You know what? I'll show that later, but you can see through the package maybe. It says DC plus stepper motor, 2 stepper motor, 4 DC motor. So it's exactly like this, the one I have below, a 4 DC motor, 2 stepper motors. But this guy works with I2²C, okay? So it's just 2 wire to control it, and we'll see when I get that working. Anyway, what I have here today. So first thing first, I did play around with this board and the software that came with it, and was able to do a few things with the motor, even change the speed. So I couldn't understand why I couldn't control it from the Gobot, so my Go code. So I decided to connect my Saleae Logic probe to the pins. So the first 3 over here, those are pin. So let's see, I run the, so I'm connected to the Raspberry Pi, and I run the pinout program, and so you can see 11, 13, and 15. Now, how do I know 11, 13, and 15? Well, if I look at this diagram, we'll see enable 1 is 11, and then 13 and 15 are the other 2 pins for motor A. And then for motor B, well, it's 22, 18, and 16. And so 22 should be our speed. And so using that information, let me go back. Where was I? Okay, yeah, I collected my Saleae Logic probe and to those pins. All right, so if you look at the pinout, you can see on the other side, 16 is just across from 15, then there's 18, and then 20, pin 20 is no connection, and then 22 is the next one down. So that's exactly how I have these connected. So now I can see what's going on. All right, now here's the other thing that I did. So I installed a desktop version on my Raspberry Pi, which I mentioned, and I was able to, I think I mentioned in the last video, I was able to connect to use their the GUI software, which is what I'm going to show you today. And so the way I did that is, let's go back to our browser and go over to the Raspberry Pi web page. And then if you go to, I believe it's help, and then documentation, and then you click on remote, and let's zoom in a little bit, and you scroll down and you see VNC. This is remote access to your Pi graphical interface, viewed in a window on another computer, which is exactly what we want to do, because I want the graphical interface to come up on my computer so I can record it as opposed to disconnecting and all this other stuff. And if you read through this, it tells you how VNC work and how to install it. So I did all of that. The only thing I did was install the VNC server, because I don't need the client on my Raspberry Pi, because since from my Raspberry Pi, I'm not going to be connecting to another computer. So just need to update and then do VNC server if that's what you want. And you can do it graphically, but since I don't have a monitor connected to my Raspberry Pi, as you can clearly see here, and I don't want to connect the monitor from the command line, I ran this command and I enable VNC. And so once you follow that, you'll eventually, once you exit the program, it'll tell you to ask you if you want to reboot your Raspberry Pi for the changes to take effect. I also enable the I2C because I plan to use that. I don't know if that's why also it had to reboot, but whatever. You follow the instructions, and then you go download a compatible VNC viewer if you don't already have one. And once you have that installed, now you can connect to your Raspberry Pi. So I've already connected and disconnected, but let me double click on that. And so it should come up, and there we go. The first time I connected, it asked me for username and password. So I used the Pi username and Raspberry password, and I clicked save. So that's why it was able to connect this time without asking me. So once that's done, I have the Python 3 IDE idle installed. And so I'll open that because that's what I used the last time to test this code. And then I'll do File, Open, and then I'll go to, if you remember, I cloned the MotoShield thing. And so this is the GUI program. And you might also have to install Python 3. So that's easy to do. You just look around how to install Python on Raspberry Pi. And so, and the idle IDE, I think also is included, but you can also look around how to install idle IDE for Python 3 on Raspberry. I open this and then I click run. And so run module, I can't remember which one let's just do run shell. No, let's run module. And then this came up, this graphical application. So here's what I want to do. So let's motor 1, let's say forward, and then I can click start. Oh, you know what? Let's do stop. I have to connect the batteries. I have my power connected, but I don't have my external battery for. Okay, so connect that. And let's do this over again. So let's do start. And so you can see I can clearly turn that motor. I can do stop. This is the maximum speed at 101 direction. And I can do, let's say, 20, and let's do start. And you can see it's clearly slower. I can't change the speed while it's running. I have to change the speed so that doesn't turn at 10. 30. It's pretty fast for 30. And then 50. It almost seems like full speed. Let's see, 70. Maybe it's a little bit faster, I don't know. Hard for me to tell. But clearly, this can control the speed. And so if I do backwards and then I do this, you can see it's going backwards and it's slower. So from this, it seems like if this board is working. Okay, we can't see the lights underneath. That's this is where you turn on the lights. So you could probably see it coming on underneath. I don't know. But anyway, the lights are not important. I don't care about the lights right now. I don't care about getting this working. And then at the bottom is, see, to get to the motor at the bottom, I can't get to the motor at the bottom. Let's see. How do I get the resolution to change? Maybe I try that thing again. Preferences. Let's see, Raspberry Pi configuration. Let's see if this works. So host name, whatnot. Oh, set resolution. There we go. So this is pretty low. Let's see if we can get it to this guy. Say okay. Okay. Would you like to reboot now? Oh, so I have to disconnect my Visual Studio Code. Let's do disconnect, close connection. I can go ahead and reboot. So yes, I want to reboot. This means that my connection here should drop to, and it did drop. So let's see. So my objective here is to try and understand if the board has a problem, which it doesn't seem like it because the graphical program is able to turn the motor and change the speed. Or am I doing something which I don't think is the problem? Am I doing something wrong in Go? And I don't think that's a problem. I think it's more like Gobot, the GPIO support is probably buggy, or the Gobot code to support pulse width modulation on a GPIO port is probably not working. Just like we saw Gobot not being able to do the high resolution pulse width modulation on the ESP8266. So it's not necessarily the same thing, but it might be something along that line where it simply doesn't work in Gobot. So we'll know for sure because with the Saleae connected, we'll look and see the pulses that are generated when we use the Python library. And then we'll try and run the Go code and see if it's generating any of those pulses. So, okay, so we should be back up. Let's see if we can connect again. So I'll use this guy and I'll say connect. And yes, we're back up. So now let's connect with our thing. And oh, the resolution look a lot better. Oh, so this is good. All right, so let me open this. And so Pi and Raspberry and log in. And let's see. And that's good. Okay, so much better resolution. So now let's go back, idle. Let's go file, open, Motor Shield, then GUI, then open, and then run. I think I said run module. And then just, yep, here's the application. Yep, in full. So let's try this again now with motor 2. And we can see that's turning one way. We stop it, go the other way, and we can go a little bit slower. And there we go. So this is working perfectly fine. And so 10, it's too low. It's essentially stop. Doesn't do anything. All right, can hear it grumbling there. Okay, so now let me turn on the Saleae device app to capture some traces. So everything is off now. And so I'm using pin the brown, black, brown, and red for channel for motor A, and then this orange, yellow, and green for motor B. So if I click start, okay, this seems to be going a little too fast. Wow, there's some pulses there, which is weird. I didn't expect that. But maybe what I want to do is this drop down. Let's do more than 5 seconds. So yeah, let's do like 20 seconds, maybe 20 seconds. And the rate, let's see, 25 kilohertz per second is the slowest. So, all right, let's do that. And let me go back to this application here. And so forward, we'll lose, yep. And then for this motor, we'll do backwards. Well, let's do forward. And then the speed, we'll do at 50. So that should be easy to see. And then let's stop this guy, do it backwards at 100%. Let's stop this, do it backward at 50. All right, and so let's stop both of them now. And let's go see what we captured. Okay, so I need to zoom in. Yeah, so this is the same on all 3 of these, all 6 of these. And when we first started, the force motor was not turning. So let's see, let's go to that. So maybe they're all putting out that signal before you start doing anything. And then we start turning the motor. Okay, so by now, I'm in the middle of my data set here, my data points. And still all these pins, okay, they changed. All right, so let's go back to when this first changed. So the first one at the top, okay, it changed somewhere about here. All right, so here it changed. All right, so let's zoom in on that. So the way it changed is we're pulsing, and then we set this high, and then we had one of these that we continue to pulse, and the other one we held it high. So 11 we held high instead of pulsing. I think that would have been, let's go back to our code, to this thing. So 11 we held high, 13 we kept pulsing, and 15 we held high. So, and then we kept pulsing through pin 13, and yeah, now the pulse on pin 13 is not stable. And that's probably, well, because this is software pulse width modulation, so we're about 3.5 hertz. You know, it's not very stable. Okay. So then there's this gap too, in which this is low, this goes low, and everything goes low. And so there we go. This is so weird. Like, I really don't even understand why is this big gap. So then there's this little peak here that's being mirrored on all. So I didn't turn on motor 2 at this point. Like, I really do not understand. This is so bizarre. This is so bizarre to me. And so if I scroll this over a bit faster and try to see where we turn on pin motor 2, I'm looking for those bottom 3 changing from being like in sync to being different. And that's when we turn on motor 2. And I'm not seeing anything just yet. Yeah, okay, so now something changed. Okay, so after this point, somewhere here, when we turn on motor 2, this pin went high. So that's pin 22 went high. The other 2 pin remained doing their weird stuff, whatever they're doing. Oh, but then shortly after, the second pin, the third pin went high also, but then that's been pulsing, and that's very different than what we see for motor 1. Motor 1, the first pin, enable pin went high, followed by one of those other direction pin. Okay, great, we need a direction. But here we see the pulse width modulation pin, the enable pin, go high to enable it, and then the bottom pin, one of those direction pin, went high, but then it went back low, and so we see that here is transition to high. So now we have, okay, so now, but it's changing. This is so weird. And then the second pin for speed control for this guy is just weird. It's pulsing sort of weird. There are gaps in it. It's not stable. This is coming low. I really don't know. And this is control with. So if I had to conclude anything, it looks like if I'm on the right pin, but I'm not on the right pin. However this works is not straightforward to me at all. Maybe I'll email the company and see what's up. But yeah, this is super weird. Okay, so this is like half an hour, and I was hoping that I would have some breakthrough, and I didn't. I'm more confused about what's going on with the signal here out on those pins. It looked like something happened that was different than what was happening before, like over here. But yeah, it still doesn't tell me really how to control the motor. All right, those motor. All right, so I'll close this. All right, so that was a total bust. Okay, so this is the Raspberry Pi hat that I got from Adafruit. Similar to what we had before on the other SB components board, but I have to assemble it. Like I said, I bought this one, and so it's not too expensive, but it says that I think it uses this is gonna be I2C. So we'll see once I get it together. Hope this one works. So conclusion here today. I'm no closer to figuring out this board than I was last week, but hopefully with the next video I'll be able to show some success with the Adafruit board. So if you're following along with this, hopefully you're not buying all the boards I'm buying and maybe waiting to see the result before you decide on which board to buy. But if you are buying the boards, I'm sorry if I bought a board that you also bought and then it's not working for you. But if you're getting the boards to work, just let me know also. That'll be great. So yeah, hopefully the Adafruit motor control board works. I'll make a video of that next when I get it to all solid this week. Okay, take care. Have a great rest of the day. Bye.